Generative, generative AI is quickly becoming a core part of modern cloud solution. In this challenge, you will build application using Gemini on Vertex AI for the text embedding, multimodal content generation, and text to image workflow. While you are learning how to ingest the data into BigQuery from cloud storage, you will then test your understanding in a role-based arcade quiz designed for workspace administrator, database engineer, DevOps engineer, and digital leaders, bringing together hands-on building and practical knowledge. Complete every activity in this game to earn a badge. Collect the badge across Google skill by completing the game. Complete them all and show off the skill. So this is me. Where? So let's start with generative AI and data workflow. So in this lab, we are going to build an application that will generate text embedding with Gemini on Vertex AI. So we are told, hi. Lab untimed and cannot be paused. So let's read on challenge scenario. You are data scientist working on natural language processing project that involve embedding text data using pre-trained language model. Your goal is to generate vector embedding for a given text phrase to use them in a downstream machine learning task, such as text classification or semantic search. You need to write a Python script that loads a pre-trained text embedding model, compute the embedding for each forgiven sentence, and then print out the length of resulting vector for analysis. So task one is to develop the Python function named text embedding, then with argument prompt. This function should invoke text embedding 05 model using the supplied prompt and generate the response. So these are the steps. So let's start the lab. Click File New to open code editor. Which so so before we open the code editor, it should open in the cloud. So I'm waiting for it to provision the lab resources. Okay. So it's just a simple lab. So I'm supposed to file a new file. Then I do what? I have no idea on how to do this. Let me just use the AI. I have no idea. So we are told we imported the text embedding from Vertex language model. So this one, then this is the function. Up to there, that is the function. So we initialize a specific model here. Then we get the embeddings. So by inputting the prompt here, then we extract the first results. Then we print the length of the vector. We return the vector. If not so, if we try this and it does not work, we return an error. Okay, it's not complicated as I thought. So let's try it. Then we file save. We try to run it here. We paste. So we have the dimensions here. We have the length, but we have some errors. So let's check the progress. So we have tried one. That is a tough one. So let's check our errors. print. Alright, this is CS50, and today we are just not writing code, we are doing something that feels a little like magic. Imagine you have a giant infinite library. In the library, books are not organized by alphabet, but they are organized by meaning. So books about dog are right here, books about cat are just an inch away, books about, I don't know, hamburger are the way on the other side of the room. Now look at this line here. Okay, model is equals text model embedding from trend. So we have we have a super smart librarian. His name is text embedding 005. We are waking him up and telling him, get ready, I'm going to get you some work. The library has read everything, every book, every website, every tweet, so we understand how the word relate to each other. So next we hand them a note. Our prompt: natural language processing is fascinating. So we pass it right here. Embedding is equals to model get embedding, then we pass the prompt. Now here is the secret sauce. The librarian does not read the note. He takes the sentence and turns it into a list of number, a vector. Why numbers? Because computer don't understand feelings or word like fascinating, but they understand math. They understand number 5 is closer to number 6. So the librarian hands us back this list, this vector. Okay, vector is equals embeddings dot value. So this is a list. How many numbers did you use to describe the list? The number was 768 numbers. This means our librarian used 768 numbers to describe the soul of our sentence. Number 1 represents, is this about technology? Number 2, is this app is a sentence? Is this about food? We don't exactly know what each number means, but altogether those numbers act like a GPS coordinate. They tell the computer exactly where thoughts lives in our universe of meaning. This is code is just it's not just printing number. It is taking human language, messy, complicated English, and turning it into precise map coordinate that a machine can use to understand. So that is how we talk with okay. That was a tough lab. 10 minutes. That was a tough. Okay, let's do another one.